This is very interesting problem based on the reactions of metal carbide. The reaction of aluminum carbide Al4C3 with water leads to the formation of. The given options are methane, propane, propane. As soon as students look at the 3 carbon atoms in the metal carbide, they think of any one of these options: propane, propene and propane. But all these are wrong. The correct answer is methane. Generally, in the exam, 3 metal carbides are asked very often. First one is calcium carbide. What will be the product, the reaction of calcium carbide with water? Second one, aluminum carbide. This is the formula for aluminum carbide. What will be the product in this reaction? Last one, magnesium carbide. This will be something different. The molecular formula will be something different. Mg2C3. Upon reaction with water, what will be the product? Generally, students memorize this. If you memorize during the exam, there will be some confusion and you may give the wrong answer. Let's go to the products also. The case of calcium carbide, we get acetylene. Case of aluminum carbide, we get methane. Case of magnesium carbide, we get propane. My memory is poor. I don't memorize this. Instead of that, I follow some mechanism to get the product. First, let us take calcium carbide. The structure of calcium carbide is written like this. Basically, it is polymeric structure. The valency of calcium is 2. For carbon, it is 4. I have written in such a way that the valency of calcium and carbon is fulfilled. Now, to this, I add water molecule. Water is nucleophile. This will attack electrophilic metal atom. When calcium is attacked, this will go over carbon. You will get C minus triple bond, carbon and Ca, and it goes on. Now, this minus charge will take this proton. OH will be added to calcium and H will be added to this. What we get is CH here, then triple bond, C, calcium. The same reaction can take place on this calcium also. What we get is acetylene. Acetylene gas is used for welding purpose. The welding shop, you can find a tank. Basically, calcium carbide is taken in that and water is added. During that time, acetylene will be generated. That will be mixed with oxygen and it will be used for welding purpose. What about aluminum carbide? There are 4 aluminum atoms. Aluminum valence is 3. So I propose a structure like this. Aluminum valence is 3. Next one is carbon. I go for a single bond because carbon valence is 4. Then after that I take aluminum. Aluminum valence is 3. So I take a double bond here. After that, there will be one carbon. Already there is double bond, so I get one more double bond here. After this, there should be a single bond. Then carbon valence should be fulfilled, so I take like this. This is the structure of aluminum carbide. When it is treated with water, water will attack aluminum. This bond will go over carbon. That minus charge will take hydrogen. Again, one more water molecule will attack here. One more hydrogen will be added here. Like this, we get methane. there is no carbon-carbon bond in this structure. Because of that, we get only methane. Let's go to the next carbide, that is magnesium carbide. There are two magnesium atoms. The valency of magnesium is 2. I propose this structure. Water is added. Water attacks this magnesium. This bond goes over carbon. Now one more water molecule attacks this. This bond can take hydrogen here, or this can involve in resonance and the hydrogen can be abstracted on this carbon. In that case, what I get is a triple bond here, then a single bond here, hydrogen will be taken. Now two more water molecules can attack this magnesium, hydrogen will be added here. What we get is propyne. Let's consider beryllium carbide. Beryllium and calcium, they belong to the same group. The structure of beryllium carbide will be same as this. Because of that, in the case of beryllium carbide, what we get is acetylene.